Whoops, a little bit too loud. Hope I didn't wake you up too much. Welcome to the afternoon session. Now we start with two security tracks. First of all, we have Wolfgang Ley here talking about the OpenSolaris Crypto Framework. Wolfgang Ley is from my, also hometown, Hamburg, in the very north of Germany, beautiful harbor city, most beautiful city of Germany. Wolfgang has a strong security background. He was one, I don't know whether this is really the right expression, co-founders of the German computer emergency response teams, DFN-CERT. I don't want to steal too much of his time. If you have something to add, please feel free to do so. Wolfgang, it's your time.
Thanks, Dirk. Okay, I have the challenging task now after the lunch break to keep you all awake somehow, and especially on a topic which might sound a little bit theoretically. I try to make it not too much theoretically, and I'm sure you will see there are some interesting aspects. Even if you don't care about programming in crypto, you might be interested in using it, administrating it, whatever. We have quite a lot of different aspects in that crypto framework. Crypto framework is actually just one small part of the OpenSolaris security concepts, and the person who will talk right after me, Jan Pechernetz, will talk a little bit about certain aspects and will also make some live demonstrations. So I will skip those and refer them to the second track. So we work some kind hand in hand here. A little bit what I'm talking about. First, starting with the motivation, why we are doing this. Unfortunately, we need to talk a little bit about the glossary, because if we don't know the terms that we are using, then we won't understand how everything fits together. Then basically we have two different components of the crypto framework that I will talking about. One is the user-level crypto framework and one is the kernel crypto framework. Both have two different parts. One is the provider of actually algorithms of whatever doing the crypto, and one is the consumer. And we have this on both sides, but we will see that later on. We'll talk a little bit about administration and debugging. Example code. The example code, of course, is too long to be presented on a slide here. You will find the entire code in the proceedings, but I will talk a little bit about pseudocode so that you get an idea of the different APIs there. And last not least, talking a little bit about the current and the upcoming projects in this area. First of all, why are we doing that? Actually, cryptography is used in a lot of places. In the userland, we have SSL, including OpenSSL libraries. We have PAM, GSS, Kerberos, SSH, whatever. A lot of applications, and everyone is always implementing the same algorithms over and over again. I don't know if you have ever tried to just check how many MD5 calculation implementations we have in the code. It is quite interesting. The same applies for the kernel, where we have different consumers, like for IPsec, for the wireless LAN drivers. You need cryptography in a lot of places there too. Unfortunately, without the crypto framework, previously every of these consumers had to implement the algorithm by itself. This has various problems. One of it is not extensible. I just make an example here. When you try to add elliptic curve cryptography, which is a new algorithm, then you would have to change all of the applications and implement it all over again, and that would be pretty hard. You have no central management. For example, if you consider the MD5 digest is too insecure and you just want to use SHA, then you have no way to disable MD5 on the entire system. Last not least, enabling hardware acceleration is quite tricky, because without the crypto framework, you would have to make your application specific to this hardware accelerator. And you don't want to do that, because otherwise you would have to implement it over and over for each vendor, for each hardware acceleration, whatever. There have been several attempts to solve the issue. We have a few userland solutions, like the OpenSSL libraries. We have the Mozilla Netscape security suite. We have implementations in Java. But again, every one of those standard solutions is implementing it over and over again. And one of the problems, we don't have a real uniform API for that. I don't know if someone of you has really used OpenSSL in depth, then you will see that the API changes from implementation to implementation. It's rather hard to keep up with the current version. After we see that the first attempts only partially solve the problem, of course someone starts a project to standardize everything. And one of the standards that actually has been established pretty well was coming from RSA, from the security division there, and they developed a public key crypto standard. Actually, there is a whole bunch of these standards, and one of them, the standard number 11, is specifically talking about a generic and flexible API on how to use actually crypto. There are more other available public key crypto standards. I've listed some in the papers, and you will see it at least in the references there. The idea of the crypto framework then is to create a pluggable framework so that you can actually extend the functionality in the userland and in the kernel and make then the software to use this framework. So there are several steps involved here. Like I said, a little bit boring but needed. We need to talk a little bit about the terms that are actually being used here. This is quite important, not necessary for this talk here, but if you ever try to read source code, documentation, standards, whatever, you will always stumble over these kind of terms. So it's important to have a rough idea what they are, and you don't have to remember all of them. I think most of them are not used during this talk, but I sometimes use them here and now. They will always be available as a reference in the paper. The first one is the PKCS 11. You will hear this very often. We already had that a slide before, and that's actually referring to the public key crypto standard. Like I said, number 11, there are other standards like defining the key format, like defining on how certification works and so on. But this number 11 defines an API, and this API is the crypto key, at least it is a pronounced crypto key, and it consists of two different parts, a consumer and a provider. A consumer is something who's using it. A consumer is someone who is using crypto in whatever way. That might be a userland application, that might be a kernel module. Whoever is using something is called a consumer in this crypto framework. And then we have a provider. A provider is actually someone who is offering an implementation, something where which the consumer can be used. Okay, this looks pretty straightforward, but that's not all. Actually, we have some more terms. One of it is plugin. A plugin is kindly different from a provider. The plugin implements some certain mechanism, or let's say it even more, it collects mechanism and you can plug it into the crypto framework. The mechanism itself is a combination of algorithms, optional with mode, and the way it is being used. It sounds a little bit complicated, because an algorithm, for those of you who have dealt with cryptography, DES, for example. DES is an algorithm on how to encrypt something, but you can use DES in different modes. And the combination of the algorithm and the way how it is used together is a mechanism. Or you can use the same crypto function for authentication or for encryption. Again, two different parts. And always the combination of algorithm and the way it is being used, that is one mechanism. The advantage of this is once you have defined the mechanism, you also know what kind of keys do you need, what other arguments, whatever are required here. We have a token. What's a token? A token is actually something which implements such a mechanism, like we are using triple DES for authentication. Whatever is implementing this specific mechanism, that is called a token. We can have several implementations of that. The reason why we can have several implementations of it, one might be in software, one might be in the hardware crypto accelerator. So we might have different implementation of the same mechanism, and these are called tokens. A token can also store some information which is required for use of this mechanism. For example, a key, an initialization vector, whatever. These tokens, as I said, can come in two different flavors. One is a hardware implementation, one is a software implementation. When we talk about the tokens, like I said, implementing a mechanism, then we have a slot. A slot is actually a collection of those tokens. That is, we're using several of these tokens. Let's say we are using all of the software tokens, and then this is one slot which can be used. And this slot is actually the connector between the consumer, between someone who is using it, and the provider. There's one special thing which is called the meta slot. This is special to Solaris. That is not part of the PKCS 11 standard. The meta slot is a virtual slot, which is actually a collection, a kind of superset of all other slots. And this is used as the default. The advantage of this is that an API does not have to care to select one specific slot. If you closely follow the standard, then you first have to select a slot to use, and then you can use cryptography using that slot, which is usually not necessary. There might be very few exceptions, like when you want to store a key in hardware and you want to ensure that it is stored in the hardware storage. Then you might want to select a specific slot, but otherwise you can simply use the meta slot. The advantage of the meta slot is that you have less code to use it, and the crypto framework will automatically select the best available token. So like if there is a hardware acceleration available, it will automatically use the hardware accelerator. We are nearly done with the boring parts. We have one thing called a session. A session is actually an active connection between a consumer and a token. This is something like opening a file, opening a socket, whatever. You open a session in the crypto framework, which is basically you open a session, do your crypto, and close the session. Last not least, we have objects. Objects is a very generic term for store any kind of information. It's a kind of bucket where you can put in whatever needed. These objects are actually two different flavors. One is only valid during the lifetime of the session, and you can also have persistent objects. Persistent objects are stored either on the hardware or on the file system, wherever, where you need long-term information. Like after you have created a key, you can choose whether this key is only valid for this session or whether you want to have that key for whatever time later on. Like I said, it is very hard to keep all of these new terms in mind, so please see the paper. And actually you can use the paper as reference too. If you go on later on, read some source documentation, whatever, take the proceedings just to get a kind of reference to understand it. Okay, after that short introduction about the used terms, I want to talk a little bit about the user crypto framework. We have parts of the user crypto framework. One is the library. The library, of course, is being used by consumers. We have software plugins. Those plugins actually implement the crypto mechanisms. And we have also a plugin to access kernel. We have an administrative interfaces. I will talk a little bit about that. Like I said, there are some details on the presentation then from Jan coming after my talk. We have a special thing in Solaris, which is a subsystem to verify the integrity of the complete crypto framework. This is not only for user level, it will also be used for the kernel-level crypto framework, but we will see that later on. And I will show some applications who are using this. As I said, libraries. Okay, we have different libraries. The main library in Solaris is the libpkcs11.so. And that library actually implements the complete API. And actually, right now, it is API in version 2.20. As I said, the RSA is a standard, and on the website from the RSA, you can get the complete standard, including the defines, the API, and so on. We have extended the official API with two different extra functions, which are private to the Sun implementation. One is sunwc getMesh session, which actually just combines about 4 or 5 of the other API calls into one. This just makes setup much easier. We will see that in the example code later on. It will just help you to initialize things easier. And the other one is key to object, where you just translate or transform keying material to a specific object, because the implementation used by the API is a little bit different. We also have a special engine called PKCS11. That's an extension of the OpenSSL library. The OpenSSL library itself offers already an engine. Engine is a kind of framework where you can also kind of plug in additional stuff. And this PKCS11 engine is a special addition to the OpenSSL. Once you activate this engine, then you will actually use the